Okay, so this last video for this example of Silicon Dynamics and their decision to build uh, computers or sell the rights to their chips, we're going to summarize everything in what's called a decision tree. So the book has another good example. I encourage you to look at their example about drilling for oil and doing the decision tree. But here is the decision tree for the Silicon Dynamics example. So step one in the process is to draw the tree. So essentially from your earliest decision, you kind of draw branches and these nodes that I've got at each of here, two types of nodes. We can either have a decision node where we make a decision as the organization, or events, meaning something random happens. Okay. So the first decision that we probably have to make is whether we want to do market research or no market research. Okay. And so we used a square to represent a decision node, and we're either going to go down one path or the other. If we choose no market research, then we don't get the additional information, and we have to make the decision on whether we want to build the computers or sell the rights. If we sell the rights, we're going to get 15 million either way. But if we build the computers, there's a difference in what happens. Either we sell 10K and get we break even essentially, or we sell 100K, in which case we net a big profit. Okay. On the other side, if we do market research, then there's the random event of whether we get an unfavorable market condition response or a favorable market condition response. And then for each of those, we have the build or sell rights choice. And if we build, then there's the two possibilities of selling either 10,000 or 100,000 parts. Okay. So that is the kind of step one, is to draw the tree, and I've gone ahead and kind of drawn it out here. I will scan these notes so that you have them at the end, but you can also follow along. Okay. Step two in the process is to use Bayes' theorem to compute probabilities. Okay. And the thing to do is we're going to write those probabilities on here after every event node, because the event nodes represent sort of random chance happening. Okay. And the thing to remember is the probabilities that we write down are conditional on everything further up in the tree, so farther to the left in the tree. Okay. So let's maybe start off with the first ones. Is this event node here, if we look at it, it's got no events farther up the tree than it. And so if we don't do market research, the only probabilities that affects how much we sell are the prior probabilities. And so I'm going to put those in parentheses of 0.6 and 0.4. Okay, and so I'm going to do this step in blue. Okay, just so that I remember that the blue are all the probabilities. Now for the, let's go back to the top of the tree. So sell 10K or 100K. This is under the UMC branch. So we're going to look at the probabilities of selling 10K or 100K conditional on any events farther up in the tree. So this will be conditional on UMC. And so then I'm going to actually look back at my kind of probability tree. Notice there's a difference. Here's the decision tree. Here's the probability tree. So you can actually kind of off to the side do a probability tree in order to help you with this step too. So selling 10K given UMC. So 10K given UMC is going to be the 0.785. And selling 100K given UMC is going to be the 0.215. Okay. Notice that these probabilities add up to 1. Okay. Down here, these two are conditional on a favorable market condition. And so I'm going to use those probabilities. And so 10K conditional on a favorable market condition is 0.257. And conditional on 100K conditional on favorable market condition is 0.743. Okay, so that's all of these event nodes, but I also have an event node back here where I split off between UMC and FMC. Now there's no more events further up in the line, and so they're not going to be conditional on anything. And so these ones, I want just the unconditional probabilities of UMC and FMC. And so that's going to be this 0.65 and 0.35. So 0.65 and 0.35. Okay, and so all of these probabilities in this top part of the tree came from Bayes' theorem and kind of the steps that we did to compute these posterior ones that go at the end. The unconditional ones go for your evidence or your findings. Down here where we didn't do the market research, we're using the prior probabilities. Okay. So that's step 2. Step 3 is add values down each path. So essentially, anytime you do a decision or an outcome produces a value or a cost, we're going to write that down on here. And so if we do market research, that's going to cost us minus 1 million. Okay. If we do no market research, that's going to cost us 0. Okay. If we sell rights, that's going to give us a value of 15. If we build, and you kind of look back at the original problem, building itself is minus 6. If we end up selling 10,000, we get plus 6. And if we sell 100,000, we get plus 60. And so really, we've always, to this point, been combining the 6 and the minus 6 to write that as 0, and the 60 and the minus 6 and writing that as 54. But we can split this. You could also write, you could definitely slide this negative 6 down and combine it with both of those and not put it separately. Okay. Favorable market condition and unfavorable market condition. Once we paid the 1 million, they don't provide any additional value or lose any value. But then we'll get the same things along each of these branches of when we build, it costs us 6 versus selling rights is 15. And we get back 6 if we only sell 10K, but we get back 60 if we sell 100K. And then build is going to be minus 6. Okay. So that's step 2. Or no, step 3, sorry. Or that's part of step 3. That's putting the values on the tree. Now step 3 is actually to add the values down each path to get a sort of payoff of each branch of the tree. So here I'll go ahead and write payoff up here by adding values down the branch. And so if I look down this branch, I've got -1 plus 0 minus 6 plus 6. And so this overall has a payoff of -1. And so if we do the market research, comes back unfavorable, build and only sell 10K, we get a payoff of -1. Okay, so not only did we break even by just selling 10K, but we spent $1 million on market research. If we do this path, that's going to be -1, minus 6 plus 60. And so that's going to be positive 53. So our previous 54, but minus the 1 for the market research. This one's going to be 14. -1 plus 15. Here we're going to get a -1 as well, and a 53. And here we're going to get a 14. Okay, so the top branch here and this branch to get the same payoffs. Now let's kind of go down the bottom overall branch. We don't pay for any market research. And so this path will net us 0. This path will net us 54. And this path will net us 15. And those were kind of all the values that we used in our original problem. Okay, so that's step 3. Step 4 is now to compute the expected value at each node. I'll add there. Okay, so we want to compute the expected value at each node. If we run into an event node, we compute the expected value with each using probabilities. So essentially, here I'll do this first one. Okay, so we move from right to left. Okay, so we move up the tree or maybe down, depending on your perspective. And so here we've got 0 and 54 are the values coming into this node with probabilities 0.6 and 0.4. And so if we kind of take 0 times 0.6 and 54 times 0.4, we get a value at this node of 21.6. Okay, and that's what we computed previously. So that's at an event node, you use the probabilities times the value that you have from the previous node, or really we can kind of consider the ends of the trees as nodes as well. So kind of maybe might be helpful kind of draw a node symbol at the very end of each of these branches, which have the payoff associated with them. At each decision, choose the best alternative. Okay, and so this decision, I look back at for the most recent value, and so that's 21.6 along this one, 15 along this one, and 21.6 is better than 15. And so what I'll do is I'll draw a kind of bars through the decision I don't want to make, and this is the decision that I do want to make. Okay, so and then I choose the value, bring forward the value from the better alternative. Okay, so let's do that with the rest of these. So I'll do -1 times the 0.257 and 53 times the 0.743. Let me pull up my calculator. Okay, and that will give us 39.1. I'll kind of point out that it's the same calculation as this, but I've subtracted one from both of those. And kind of as a result, it subtracts one from the expected value. Okay. Up here, I'll use these two probabilities and -1 and 53 to compute the expected value. And that will give me a value of 10.6. Which is one less than this 11.6 because I'm using -1 and 53, which is one less for both of those. Okay. So there I'm using the probabilities for event nodes. Now I need to look at my decision nodes here. And here I compare the 10.6 to the 15. 15 is better than 10, or no, 14 is better than 10.6. And so I'll block this path and I'll bring the 14 up there. Here I've got 39.1 compared with 14. 39.1 is better than 14. And so I'm going to cross off that path and write the 39.1 here. Now I use the 14 and the 39.1 with these two probabilities to compute the expected value at this node. And if I do that, I should get 22.8. Let me pause the video. Yep, that's 22.8. Notice it's the same computation that we did to get the 23.8, but we've already sort of subtracted off the 1 from both of these two numbers that was the cost of our experimentation. Okay, so then we get the 22.8 at this decision node or this event node, and now we're worked back where we're ready to do this decision node. We can look down this decision node and see 22.8 here. We can look down this decision node or this branch and see 21.6. 22.8 is better than 21.6. So I'll put a cross through that one, and my overall value of this whole decision tree comes from this node, and that's 22.8. Okay, notice this is one less than the 23.8 that we computed earlier because it incorporates the 1 million cost for research into it. Okay, so the sort of overall expected value of this scenario would be you pay the 1 million for market research, depending on whether you get UMC or FMC for the market research. If you get unfavorable market conditions, you sell the rights and get 14. If you have favorable market conditions, you build and you get whatever the kind of result is, either -1 or 53. So sort of the three possible outcomes if you choose to do market research are still sort of sell rights for 14 million, uh, build and only sell 10K, and now you're out, you're down 1 million, or you build and sell 100K and then you get plus 53 million. The thing is, by doing the market research, we've changed these probabilities relative to what the prior probabilities are, and so it's a better outcome, even though we spent the 1 million to do the market research. Okay, so this sort of kind of summarizes everything we did. And yeah, step 4, compute the expected value each node, moving from right to left. So that's it for this example in this video. I do encourage you, read through the books, Drilling for Oil example, to see another kind of fully worked out problem of a decision analysis and the decision tree at the end. But thanks for watching.